Dear friends, welcome back to Data Analytics Talks. The last two videos I have been focusing on PostgreSQL. PostgreSQL is the most popular object relational database. So when I say object relational database, there is a difference between relational database and object relational database. In the object relational database, it can manage any type of object. The object could be document, object could be images, object could be audios, videos, or tabular format data. So any type of data can be stored and managed in this kind of object relational database. And PostgreSQL is the most popular open source object relational database. So the first video I have covered how to set up PostgreSQL in your system, and in the second video I have elaborated, or I have made a walkthrough of the interfaces and the features of the PostgreSQL database. And this particular video I would like to take you along with me a tour of the SQL scripting part. What I would like to show you is how to create a database. The database can be created through the declarative way, and also it can be created using scripts. So I would follow the declarative way of creating database. Then let us look into how to create types. Types could be the enums, and the domains is something similar to the data types, and the sequence, the aggregate functions, the tables, the views. One more step ahead, we will see the materialized views and the trigger functions. So I am sure this video will give you an introduction to the basics of PostgreSQL, and you will understand how the SQL script is similar to what we do for SQL Server. So welcome to PostgreScripting. So what you see is the pgadmin4 interface, and on the left side you can see the servers that are installed on this system. So you can install multiple servers side by side, and that's how it is called the clustering of PostgreSQL. So when you install multiple servers in a system, that concept is called as clustering. So I am not gone into the clustering aspects of Postgres. I just installed a server, and this version of the PostgreSQL is 1.6. So if you look at, you can see all the databases, and the number of databases are 4, and these are the databases I just created for exploring. So there is a demo, there is a DVD rental one, and there is a Postgre. This is the default, and there's another test one. So I will create a new database. Let me just right click on the databases, and I just create the database. I will give DVD rental demo. Okay, so the rest is all default. No, there will be an owner to be assigned, and that is the default owner, and you can see the definition. So if you want to make any changes, you can choose the right values from this wizard. And if you want to set up the security aspects, privileges, you can give the privileges by adding the users. That is possible at this level. And you can also go to the parameters. If you want to set parameters, you can add parameters. Okay, this is possible through this wizard. And the advanced version, you can the schema restrictions, you can specify the schema restriction. Then finally, whatever you set, it will be seen the SQL script for the corresponding configuration. So create database DVD rental demo, and with owner Postgres, and encoding is UTF-8, and local provider is LIVC, and connection limit is -1, is template equal to 4. So of course, when you create a database using a script, you can mention the template name and make it as a true. So I am not going to make any changes. This is the default setting. I just give the database name, and let me just save this. So this is going to create a database for me, and under the database, we have all the building blocks like cast, catalogs, event triggers, extensions, foreign data wrappers, languages, publications, and schemas, then subscriptions. So these are all part of this every database. So what we need is we need to expand the schema. By default, there is a public schema. Of course, if you want to have a new schema, you can create a DVD and schema, and again the owner will be by default assigned. Again, you can set the security, you can set the default privileges, and you can see the definition of SQL definition for your schema creation. So it's create schema, the schema name, and authorization. Again, by default it is a PostgreSQL. So let me save this. So another schema is created, but this is just for demonstration, and I will be creating my objects under the public. Okay, so what I will do is, let me go to the database. I right click on the database. I can choose either PSQL tool. This is a command line tool, and I can also choose the query tool. So yeah, because there is a user interface, query tool is most appealing. So let me copy some code which already I have collected. Okay, let me help you understand this code a bit. So what are we going to do? We are going to create type, we are going to create a domain, we are going to create a sequence, we are going to create aggregate, tables, views, materialized views, and trigger function. So since the database is empty and does not have any tables, so if you create views or functions without the tables, the database can complain, and your script can fail. So before you execute any script, let's set the environment variables. So first environment variable is statement timeout. You set to 0. Then log timeout, set to 0. Idle in transaction section timeout 0. Then client encoding. Then standard conforming strings on. Then pt catalog set dot set config. Then check function bodies. For example, if you create a function and there is no valid table exists, maybe they try to run the select query, this will fail. So we are setting this to false. That means no function body check, just creation of the function. So let me execute this part, or I will execute it later as we complete the explanation of various building blocks, right? So let me start with the type. So how to create a type? There is the syntax for creating the type is create type. The schema is public, and again you should give the name of the schema, the name of the type. So MPA underscore rating. So we are storing the DVD, so we need to store the rating. So what are the valid values for the rating? There is a G, there is a PG, there is a PG-13, there is R, there is NC-17. So these are the approved values for this rating. So we create an enum. So this is a type of enum, right? Enum. Okay. So create type, then you mention the schema, then the name, and give all the approved value values for that. So then once you create the type, you have to associate the type with your user. So by default, user is Postgres. So let associate this after creating the type. Okay, so I will run this code little later, but let's get us familiarized with all these things. So next one is a domain. So create domain. You have the schema is public. The name of the domain is year. So what is a domain? Domain is nothing but a data types. So custom data type. So when you say I need to call a data type as year, the type is integer. So year will accept only integer values. We have to have a constraint, the year check constraint, which will check whether the value is greater than or equal to 1901 and less than or equal to 2155. This is a custom data type. Again, the data type is inheriting from integer. So it's a integer. So again, once it is created, we will be associating this with the particular user. So this is the create domain. Okay, we have seen how to create a type. Then now we have seen how to create a domain. Now we will see how to create a sequence or functions and so on. So let me go back and show you how to create a function. This is create function, a schema, function name, then parameters, then return text. So it's a concatenation. We are sending two text messages. So checking if the messages having value, then it will be combined using a comma, separate comma. So maybe first name, last name, then first name, comma, last name. So if first they will check whether both are having value, whether one is having value, the other is not having value, like put a logic inside the function, and this is used in our program. Let me once the function is created, we will be assigning the ownership for the Postgres. The syntax is again the create function, schema, function name, parameters, return value, then the logic for the function. That is a function. So next one is we are going to create an aggregate function. No, so for that we use the syntax create aggregate, then the schema, then the name of the aggregate function and the parameters and the logic for the aggregate function. We can see that once it is created, we will be associating that aggregate function to the user. So we've seen the aggregate function. After that, we will see the sequence. Sequence is generating unique key for the tables. In this case, we have actor ID. So for the actor table to generate the next sequence number for the primary key, there is a sequence creation. So create sequence, the schema, sequence name, then start with 1, increment by 1, then there is no minimum value, there is no maximum value, there is a cache is S. This is the syntax for creating sequence, and once the sequence is created, this will be associated to the owner, that is the Postgres. So again, finally, now we have seen how to create aggregate, create a sequence, create a domain, create a type, and also we have seen the domain part. Okay, now we have going to see how we create tables. Tables. Tabular data being stored in tables. Let's create a table actor. Actor will have actor ID, first name, last name, and last updated value. Actor ID will be a primary key, and it needs to have the default value. That means next sequence value. So we can call a sequence function from the definition, and what happens is like always it gets the latest ID for the actor, and you can mention the constraint not null or null. Then we can mention like other data types. It could be integer, character, timestamp, date, all those types that can be mentioned. So this syntax is create table, public, actor. Then once table is created, of course, we are going to associate that table with our user. So that is the table creation. What we have left is creating the views. So let me show you how to create a view. So views are virtual tables, so they don't store data in those views, but they fetch data during the load time. And the beauty is that it can have the business logic built with it. Here you can see create view, or the schema on the view name, there's actor info, and it is combining joining multiple tables. So the group contact, you can say that there is a tables called film category, film, and film actor, and categories. So we get the views from the desired view, or the output from joining with multiple tables. That's a view creation. So create view, that's syntax for creating the views. So once views are created, of course, this has to be associated to an owner. So finally, we have something called a materialized view. So if you look at the schema, and if you expand the schema, of course, you can see a materialized views and views. So you need to understand the difference between materialized views, and views are just a virtual table. They don't have take any physical space in the database. But material views, they take physical space in the database, and it is a temporary physical table which will store the result of the logic that you have built in the view, in the materialized view. And this is very good when handling the large data set to populate your reports or dashboards. So materialized view. So how do we create a materialized view? There is a syntax called create materialized view. Then you have the schema, then the materialized view name, and you should write your logic, and how do you join your tables, or any kind of calculations you can wrap within this view. And always view returns the result set. So you can see that when you create, you can mention with the data or with the no data. With the no data means it won't be populated. So while you are loading, you have to refresh the view. Only then you can see some data. With the no data, with the data is very important in the case of materialized view. And once you create the materialized view, of course, you have to associate that view with some user. So I have explained to you all those concepts which I have initially put in my agenda: the type, domain, sequence, aggregate, table, views, materialized views, and trigger action, trigger function. So a function which returns a trigger is a trigger function. So let me execute the whole story here. Of course, very quick. It has created all the script which I've written. So what I will do is I will try to refresh my database now. I'll try to refresh my database. So of course, we will see some of the created objects. So we can see under public, we have created domain. So we have year as a domain. We have a check constraint for year check, that is variable created. Then we have functions. We have created so many functions. So we have a group concatenate, film in stock, and you can see these parameters in part of these definitions. Then we have materialized view. Yes, I have created one materialized view. So we can see the columns I have added for the materialized view, and it has an index created. Then coming to that, we can also see some sequences. So sequences for each and every table that is being created. So all these sequences will provide you unique IDs for this table. So we have 15 tables like actor, address, category, city, country, customer. So when you expand this, you can see the columns for each table, and you can set any rules, policies, or triggers for this table. So we have film, we have all this part of it. Then we have a trigger function. As I said, a function which returns a trigger is a trigger function. And we have the types. I have only the one type, MPA writing. And finally, we have multiple views for this databases, actual info, customer list, film list, my server slower than film list, and sales film category, sales by store, and staff list. So that means whatever I shown you in my script, and they're all executed very well in this database. What do you think? Like when you compare SQL Server with PostgreSQL, of course, there are little bit of syntax differences. So I think we never see this kind of syntax in SQL Server, but in PostgreSQL you see a little bit different, a different type of syntax. If you already know the SQL, I think the learning curve is little easy in Postgres. So these are some of the way how the variables are declared in Postgres. I think there is a lot of documentation available in the internet, also in the Postgres web portal. So spend some time understanding the SQL, advanced SQL. So the skills can really take your career into another level, especially areas where companies mostly depend on these open sources like PostgreSQL. Thank you very much for watching this video. Hope this was really helpful. I am interested to listen to your feedback. Don't forget to make your comment or criticism in the comments box below. Thank you.